this video presentation, I will be presenting an important topic of data warehousing, that is inventory. As we move forward in the presentation, it would make things clear as to why this topic plays an important role in data warehousing. The current slide that you're looking at illustrates an example of a retailer's value chain. The purchase order goes to a supplier, which in turn becomes the shipment order. The manufacturer then ships the order and it becomes part of the manufacturer inventory, and then the warehouse inventory. When the carrier delivers it to the supplier, it becomes the supplier inventory, and so on and so forth. It's important to understand the inventory models when we study inventory in data warehousing. There are three different types of inventory models, each having its unique features and benefits. The first method is the periodic snapshot method. In this method, the product inventory levels are measured at regular intervals and placed as a separate row in a fact table. The second way is the inventory transaction, in which we record every transaction that affects inventory. The third process is known as the inventory accumulating snapshot, which has a definite beginning, a definite end, and identifiable milestones in between. Now let's look at each inventory model separately. The first model is the periodic snapshot model. If we provide the right product at the right place at the right time to the customers, from a retailer's perspective, it would minimize and reduce the inventory carrying cost, which means the cost of the inventory carrying would be minimized and reduced at the retailer level. Since the inventory levels are measured at regular intervals in this model and updated as separate rows on fact tables, if we have a chain of stores, for example say 100 stores, and each store carrying different types of products, the data warehouse would become very dense because each product would have each row on the fact table. So to deal with this kind of situation, it is good to reduce the snapshot intervals. For example, an interval of a month, an interval of a quarter, interval of a year. The inventory is additive in some dimensions, but not all dimensions. And that is why the inventory facts are called the semi-additive facts. Due to inflation, deflation, inventory on hand, beginning balance and inventory on hand ending balance would be different. As a result, enhanced inventory facts are to be added to the fact table as well. The second model is called the inventory transaction model. In this model, the inventory is recorded at all levels. This could include receiving product, place product on hold, release product, from hold, return product, release product from hold, return product to vendor on failure, place product in bin, package product for shipment, ship product to customer, receive product from customer, customer returns, remove product from inventory. However, the downside of this model is it's a lengthy and cumbersome process. The third type of inventory model is accumulating inventory snapshot model. In this model, the disposition of product is on single row, which means the product is tracked on a single fact row until it leaves the warehouse, which means going to the warehouse, leaving outside the warehouse belongs to one row. We can measure the disposition in lots Also, this model has identifiable milestones. These identifiable milestones could be different dimensions, such as date. For example, on Tuesday, the lot could come into the warehouse. On Wednesday, the lot is inspected in the warehouse. And on Thursday, the lot leaves the warehouse. And all these processes would be on a single row. Like we have different types of inventory models, similarly, we have different type of facts tables. The fact tables are similar to the inventory models: transaction fact table, periodic snapshot fact table, accumulating snapshot fact table. The figure illustrates a clear description of each type of fact table and its characteristics. For example, a transaction fact table has a time period of one point in time, whereas periodic snapshot would have regular intervals, and accumulating snapshot would have a time span, but typically short-lived. Similarly, if you look at the date dimension characteristic, the transaction table would have a transaction date. Periodic snapshot inventory model would have an end of period date. The accumulating snapshot would have multiple dates for standard milestones, because accumulating snapshot has a beginning date, an ending date, and an identifiable dimension. So that's where the standard milestone comes into play. Now it is very important in the value chain that the value chain requirements integrate well among each other. Both IT and the business departments are interested in the value chain integration. As a result, we are studying the enterprise data warehouse bus architecture. The requirement of looking at the customer information across process, codes, order, invoices, and customer service is very important from the business standpoint and an IT standpoint. Similarly, looking at products across these different attributes is important from both business and IT. An enterprise architecture guides the design and the business process, basically provides tools for decision making. Whereas the enterprise data warehouse bus architecture provides the best of both the worlds. It is basically an enterprise data warehouse, but it's independent of the technology and the database platforms. Also, it's coherent with the conformed dimensions and facts. Now, what do we mean by conformed dimensions and facts? We will study that shortly. The following slide provides a small but very easy to understand example of an enterprise data warehouse bus architecture. If you look at the rows, they provide the business processes. If you look at the columns, they provide the common dimensions. How this bus architecture comes into process, comes into play, comes into evolution is basically you start by individual business process rows one at a time. This provides better query performance, and it's easy to use this way. As far as the columns are concerned, it is always better to identify the dimensions before filling out the information in the matrix. So after both the rows and the columns have been identified, then you mark X across each row and column by identifying the dimension against each business process. Although this seems to be a simple architecture, but in reality it is not as simple. However, once successfully designed, the benefits are immense, such as data governance coordination, project estimation, and organizational communication. If common dimensions are changed with stakeholders, this model can evolve into a stakeholder matrix. So evolution of this model into other models is very easy. Some common bus matrix mistakes are as follows. Departmental, which means over-encompassing the roles, or report-centric, which means narrowly defining the roles. Another one is overly generalized columns, which means that a column called a name of person could mean many things, such as male, female, customers, vendors, etc. So don't overly generalize columns. Also, separate columns for each level, which means subdivision of the columns into subcategories, instead of making separate columns for each level, which makes things very difficult. As we discussed earlier, the conform dimensions. What are these and why are these important? The conform dimension should be built once in the ETL system and then replicated logically or physically into the enterprise EDW environment. Conform dimensions should be able to provide measurements from different business processes in a single report with the help of a multi-pass SQL query. Identical dimensions should be joined. For example, the month could be small July in one table, and it could be caps July or the month of number 6 in another table. So identical conform dimensions should be combined. By shrunken roll-up, it means different dimensions have different levels of granularity. So each dimension should be at the same level of gran. This could be attributed at the subset level or the row subset level. By limited conformity, the data governance and stewardship is affected. This means that if there are different products that can be combined into one category, it is always a feasible decision to do so. And last but not the least, besides the dimensions, the facts table must be conformed as well. With this, I would like to end this video presentation. I hope you enjoyed this and you could use this as a learning tool. Thank you.